Which is cheaper, eating out or dining in? The mean cost of a flank steak, broccoli and rice bought at the grocery store is $13.04. A sample of 100 neighborhood restaurants showed a mean price of $12.75 and a standard deviation of $2 for a comparable restaurant meal. Part A. Develop appropriate hypotheses for a test to determine whether the sample data support the conclusion that the mean cost of a restaurant meal is less than fixing a comparable meal at home. Because we're testing whether the mean cost of the restaurant meal is less than fixing a comparable meal at home, we'll put mu less than 1304 in the alternative hypothesis, and so our null hypothesis will be mu greater than 1304. Part B, using the sample from the 100 restaurants, what is the p-value? So first we'll write down our sample data. Sample size n is 100, sample mean x bar is 1275, sample standard deviation s is 2, and then we'll use that sample data to calculate our test statistic, which will be a t-statistic in this case, since we don't know what the population standard deviation sigma is. So if we plug in our numbers into our formula there, we get minus 1.45 for our test statistic. And then the p-value will be the tail area to the left of minus 1.45, since this is a lower tail test. To find that p-value, we can use the t-table in the back of the book, find where n-1 or 99 degrees of freedom is, look along that row in the table, and find where minus 1.45 would come. And if we do that, we can see that minus 1.66 with the tail area of 0.05 and minus 1.290 with a tail area of 0.10 lie either side of minus 1.45, which is our test statistic. So therefore our p-value must be in between 0.05 and 0.10. At alpha equal 0.05, what is our conclusion? So we've figured out that the p-value lies in between 0.05 and 0.10, so it must be bigger than our significance level alpha 0.05. So therefore we fail to reject the null in favor of the alternative. So there's insufficient evidence that mu is less than 13.04. In this case, we cannot conclude that the mean cost of a restaurant meal is less than fixing a comparable meal at home. Our data isn't strong enough to suggest that. And then part D, repeat the preceding hypothesis test using the critical value approach. So for the critical value approach, we find out which value of t would have a tail area of 0.05, and that was the minus 1.66. So that is our critical value, and so any test statistic lying to the left of that critical value, since we're doing a lower tail test, would allow us to reject the null in favor of the alternative. But minus 1.45, our test statistic, is not to the left of minus 1.66, it's to the right of it. So therefore, again, we fail to reject the null in favor of the alternative, and again, we have to conclude that there's insufficient evidence that mu is less than 1304.